And yeah, I thought we might go into today, but we got the packet done on Monday. Test number 3, remember, it's going to be available on Thursday at 6 a.m. and you got to complete it on Friday. And I'm going to start a module 9 today. Let me just go into, let's see, where is it? Oh yeah, test 3, review and test. I uploaded the answer sheet to the review packet. So you can see my chicken scratch here. That's actually not bad compared to, I think my writing's improving. And the videos are posted here as well. Let's see, the reference sheet. Oh, you can't see the test yet. Let me, well, I can see the test, it's right here, but the test will show up in the same folder. Let me go into student preview mode. Go back to that folder. Just so you're not seeing things and be like, well, why can't I see that? So right now you should only be able to see the review packet item and the reference sheet item. And the reference sheet has the, again, if you haven't printed this out already or downloaded it, let me close this. You know, do that. It's probably a good idea to have it in advance of the test. So you're not in the middle of the test, you're like, oh, I need a reference sheet. Where did I put it? It's got the specific heat table from your textbook. It's got the electromagnetic spectrum, and it's got a bunch of formulas and variables down here that you can use. All right, any last minute test questions? All right, so what I'm going to do today, get my notes out, is I'm going to start module 9, which is the atom. Let's just look at that module for a minute, because I can't remember if it was this one or the next one. Oh, yeah. The homework and quiz are already up. You can do them anytime you want. I would suggest you wait to do the quiz till we're done with the in-class stuff. The module 9 homework is, again, all as usual, based on specifically the textbook. Looks like I have a chat here. Oh, okay. Yeah, if you're late, that's not a big deal. Just we'll continue on. Reminds me of my first semester teaching. I had a student who just in the middle of class would get up and walk out and then walk back in, and I felt like I was you ever work at a store in the mall, right, where you're standing there at the register and people just walk in and out. It's like, what is this, a mall shop? Just come in for some physical science, leave if you don't like it. The overview for module 9 is here. This is again a PDF just outlining. This is basically all of chapter 8. The applying the concept questions. Again, not all of these are on the homework quiz, but you should just review them. Again, the answers are in your textbook, so the homework's not intended to be difficult. It's intended to be there for you to take, and hopefully you kind of use it to quiz yourself, right? So you sort of read the chapter, read everything, go through the homework. Oh, I got some wrong. Go back, do it again. So you learn the material. Let's see. I hear some noise in the background. I'm going to mute everyone again. I don't know if that's a microphone or what. All right. Let's see. Where's my, oh, I closed my document camera. All right, it took me like most of the semester to realize I could print out, I'm using paper anyway, I might as well print out headings on it. So module 9. We're going to talk about the atom. And this is basically the, well, module 9 itself is the atom. All right, we're gonna start with, this is the start of the chemistry section.
We're recording, right?
We should be. Let me check. Always good to. Yes, we are recording.
Thank you.
Yeah, thanks for the reminder. Start of the chemistry unit, I guess we'll call it. I'm running out of room already. So we're going to talk about some things. We got to obviously define some terms. Let me zoom in. It's very touchy. Let's talk first. Let's discuss some terms here before we get to the atom. Let's talk about matter. Matter is basically anything that has mass and volume. And chemistry chemistry is the field of study that focuses on the interaction of matter and let's put a comma, specifically within and between the tiny particles that make up matter. Specifically, these are atoms and molecules. What did I do with I'll get to it later. All right, let's talk about the atom now. The atom is a word that's it comes from the Greek, the ancient Greek, meaning indivisible. So it can't be further divided. Now, obviously, we know now that we can split the atom, but that takes a lot. That takes a lot of specialty equipment and work. But that's where the atom got its name from, right? Fundamentally, people believe there's some fundamental indivisible particle, and at some point they reached that point and couldn't get any further. Like, okay, this is the atom, right? And in the universe, there are approximately 118 unique atoms that's a period. What we talked about above, right? Matter. All matter is made up of some combination of these. And the 118 is a little bit misleading because a lot of these, especially the newer ones, are man-made and radioactive and have very short half-lives. So you're really looking at like less than 100. And I'd have to look at the table itself to count, but these unique atoms are called elements. And are found on the periodic table of elements. Which does get introduced later on. But for now, do I even have my copy up? Let's see. I guess I don't. I don't know where I put it. So atoms, right, make up all the stuff around us, and chemistry is the study of how atoms and molecules react with one another, right? How they interact, and how they form the matter that exists. I'll show you a quick, even though technically, this is what I meant about breaking things up into modules. This is the periodic table. We're going to cover this in the next module, but I just want you to see it and be aware of its existence. And this basically lists all the elements, or all the elements in existence. And it goes up to 118 over here so far. What else? Pretty much it. Oh, this is from your textbook. This is figure 817. We're going to learn how to read the periodic table in that specific module. Yeah, but I'll reference it occasionally. But we used another term here, element, right? We have an atom. An atom is the fundamental building block, right? Let's look at what an element is. An element can be broken down into, for those of you, some of you are probably laughing that I said my writing was getting better. Like, it's not getting better, it's getting worse. Element can be broken down into a simpler substance and still be itself. It is a pure substance made up of only one type of atom. So for example, gold, right? Copper. What else? I don't know, zinc. Interesting, I chose all metals here. But so the element, right? If I say I have the element, a pure element here, right? Well, that's kind of redundant. The element is gold, right? By by definition, an element is just pure substance, right? So gold is an element. It's not, there's nothing simpler than gold, right? You can have a lump of gold, and if it's pure gold, right, you can take it apart, you can cut it down into, you know, smaller and smaller pieces. It's still going to be gold, right? It's a pure element of gold. Let me just see something in the next. Yeah. I'm going to draw a little line here because this is not part of elements. Atoms can combine this looks a little washed out. I don't know. Atoms can combine in whole numbers, numbers, and whole number ratios to form compounds. Compounds are expressed using chemical formulas. Oh, fit it. So, for example, water is H2O. You probably heard about this. Table salt. NaCl. Where's my red pen? So these are atoms. The hydrogen H, the oxygen O. Again, sodium, chlorine, these are atoms. So these atoms combine in whole numbers and whole number ratios, right? So notice we got 2 hydrogen atoms and 1 oxygen atom, a ratio of 2 to 1, right? To form a compound. The compound here is water. This compound here is salt, table salt. As we'll learn later on, there's lots of different types of salt. Move this up just a bit here. All right. Well, how do these things combine? How do atoms form compounds? Well, you have what's called a chemical reaction. Chemical reaction is a process in which atoms combine to form a compound or It's a process in which atoms combine to form a compound, or a process in which a compound is broken apart. Let me see here. Yeah, I think that I don't need to write an example here. We're going to talk about this in another, well, assuming we get to the later sections. Chemical reaction, right? So this is where, for example, water, right? You've probably heard that water can be broken down into hydrogen and oxygen. So, let me actually write that. Process in which atoms combine. So one would be 2H plus oxygen produces H2O, right? So these are taking gases and forming water. In a plant cell, right? A plant cell uses the sun's energy to actually take water and break it down. They use the hydrogen, but it releases the oxygen, right? So you can also do the reverse thing. You could take H2O and break it down some process here. And break it into 2 hydrogen plus 1 oxygen. And this process could be, it could be electrochemical, but it's some kind of chemical reaction that's allowing you to go either take atoms and combine them to form a compound, or take a compound, break it down. Now you can also take compounds and make other compounds, right? But it's this whole interplay between atoms and compounds and breaking things down. All right, let's look at the components of an atom now. This is going to inform our understanding of things later on. Let's start with the proton. I'll underline that. That's an R. Proton. This is found in the nucleus of the atom. And it's hard to define this stuff without taking for granted that you've gotten certain information. But an atom, you're going to find out later on. You're going to find out how we know it has a nucleus. But it's basically the center of the atom, right? It has a positive electrical charge. And so you'll see that written as like positive, and a mass of, now you don't have to memorize this number, 1.6726, I don't even remember offhand, times 10 to the minus 27 kilograms. This is the mass of a proton. if you take this to two significant figures, so to two significant figures, I'll just write sig figs, this mass is assigned a value of 1.0 AMUs. And an AMU is atomic mass units. So someone looked at this and said, oh, you know what? This is convenient. An atom consists of protons, neutrons. We'll find out with the other neutrons and electrons. We'll talk about those in a minute. And you know, the mass of this proton is tiny, right? Let's just call this one, one atomic mass unit, right? So again, just coming up with a system of measurement that makes things easier to deal with down the road when you're trying to, you know, deal with, say, great numbers of things or, you know, mass balances. Let's talk about the neutron now. This is also located in the nucleus. Of an atom. It has a mass of 1.6750 times 10 to the minus 27 kilograms. Right? So notice very close to the mass of a proton, right? And in fact, this is why we say to two significant digits, this mass is assigned a value of 1 AMU. And we're going to find out that the neutron is also comparable. So in general, in general chemistry, sorry. In general chemistry, as opposed to things like physics. If you're doing like atomic physics, you're not going to make this assumption. But in general chemistry, the mass of one proton, and one neutron are considered to be the same. So both have a mass of 1.0 AMU. Two sig figs. Note, a neutron has no electric charge. Or electrical charge. It's neutral. It's not positive, it's not negative. There's no charge. It doesn't carry a charge. I think I'm going to start electrons on the next page because I'm running out of room here. The electron. So far we've got a proton and a neutron. They're both located in the nucleus. The electron is found outside the nucleus. Time is it? Outside nucleus. It has a mass. Well, hold on a second. Let's see. Found outside the nucleus. Oh, it moves in paths called orbitals. And we'll find out a little later on that it's just not exactly, it's not like the solar system where they stay on the same path. They move in paths called orbitals. And for now, that's okay. Electrons have a negative charge so minus sign, and their mass is so much smaller than a proton or neutron their mass is so much smaller than a proton or neutron that it is ignored in general chemistry. So the electron is not ignored, just the mass of the electron. Their mass is so much smaller than a proton. Yeah, so the mass of the electron is ignored. We're not ignoring the electron. The electron is important for chemical bonding. But those are the three components of the atom that we're going to look at, right? We're not dealing with subatomic particles here. So don't leave that to the physicists, right? That's why in general chemistry, we typically don't worry too much about this mass difference between the proton and neutron. It's not significant. If you're a particle physicist, that's a very significant mass difference, but it's not significant at all for general chemistry. And the same thing with electrons, right? We're not worried about the masses at all. We're just assuming that they're they're massless and they've got a charge, negative charge. All right, so we talked about the particles that make up, well, the components of an atom, and we talked about the charges. So let me just talk about the law of charges here. In general, like charges will repel each other and opposite charges, or, well, we'll just put opposite charges, will attract each other. So you may be thinking, well, how the heck do protons stay together? Well, maybe you don't know yet, but in the nucleus of an atom, there's usually more than one proton. And we have what's called the strong and weak nuclear forces. We mentioned these back covering energy. This was the potential energy, internal energy of the atom. Strong and weak nuclear forces hold the atom together. These were basically nuclear forces. Hold the atom together. So these strong and weak nuclear forces, this is what we're unleashing when we split the atom. There's all these forces holding this atom together. So these two are things you need to sort of keep in the back of your head when we deal with, particularly the law of charges. We're going to deal with that a lot. So let's look at the role of various components in the atom. Role of components in an atom. Just put a little dash line here. When it comes to the electrons, it's mainly the outermost or valence electrons, mainly the outermost or valence electrons put an underline there. I'll underline valence electrons. And these are the only, or sorry, they are the only components of the atom involved in chemical reactions. Geez, the way my notes are in my book, it's really difficult to try taking these out. Electrons. We're going to find out that atoms have different number of electrons depending on the atom. And the outermost electrons, they're called valence electrons. So valence electrons, if you hear the term valence, that means the outermost electrons of the atom. And these are typically the only ones that are actually doing anything involving chemical reactions. And we'll learn more about their roles later. Let's look at protons. The number, that's a number sign, of protons in the nucleus completely defines the element. And so the number of protons in the nucleus completely defines the element. What we're going to find is that all atoms of a particular element always have the same number of protons. And this is referred to as the atomic number. This atomic number is the number of protons in the nucleus of a particular element. So like gold always has a certain number of protons. it's not gold if it doesn't have that number of protons, right? And this is called the atomic number, right? The atomic number is the number of protons in the nucleus of a particular element. And so each element has a unique atomic number. All right, so electrons, they're the ones that are involved in chemical reactions. Protons basically define the element. And neutrons add mass to the atom. And are used to identify isotopes. And let me just define an isotope. An isotope is, let's see, well, isotopes are atoms of an element that have different number of neutrons. All atoms of a specific element have the same number of protons. But by the definitions down here, you can see that some of them may have different number of neutrons. So let me write this down here. All atoms of an element have what? They have the same number of protons but can differ in number of neutrons. And these are these are all in the nucleus. Where protons and neutrons reside in the nucleus. Oh, 1148. This might be, let's see. Let me write one more thing about Ernest Rutherford. And we don't know who Ernest Rutherford is, but how do we know about this nucleus? Well, let me draw a dashed line here because we're sort of changing topics. I wound up on a different page than I wanted to be. In 1907, Ernest Rutherford estimated that if you made a scale model of the atom The nucleus would be in the center, would be in the center about the size of a penny. Turn my alarm off. Let me finish this. If you made a scale model, the nucleus would be the center, about the size of a penny, and the first electron, very first electron, closest to the nucleus, would be about a football field away. That's just from the, that's just the radius, right? So the takeaway here is the nucleus is tiny, and the atom is made up mostly of empty space. Made up. There's an experiment Rutherford ran. I can't remember if I talked about it in the notes. It's mentioned in the textbook, and there's a video on it online, and in the actual material. So you can go ahead and watch that video.